Okay, let's unpack this.
Yeah.
The big one. The question that's kind of been nagging at us since, what, 1950?
Yeah, Enrico Fermi.
Right. If there are other advanced civilizations out there, where exactly are they?
Mm.
That's the fundamental question. And it's really the heart of what we call the Great Silence, the Fermi paradox. It's incredibly thought-provoking.
It really is. And what's fascinating is how this seemingly simple question forces us to confront a really deep uncertainty.
Like what?
Well, is the universe just teeming with life that we just can't detect yet? Or
Yeah.
is life itself, its emergence, actually a much rarer event than we might, naturally assume?
That's the core of it.
And this deep dive, it really explores that search for extraterrestrial intelligence. SETI, we're looking at a document that examines how scientists are tackling this huge question.
Right.
It even touches on some of the early thinking that got SETI going. The idea, way back with Cocconi and Morrison in '59, that under the right conditions, maybe Earth-like conditions, intelligent life might just pop up.
Exactly. And when you hear about SETI, it instantly sparks this huge sense of possibility, doesn't it?
Oh, absolutely.
But our source document, it makes it clear that while, yeah, the curiosity is universal, scientists are also grappling with some really fundamental principles and, well, paradoxes that shape how we even think about this.
Mm-hmm.
We're talking ideas like the anthropic principle, the mediocrity principle, the fine-tuning hypothesis. How do these actually influence the search?
Well, they're sort of related ideas, though. As the document points out, they're unproven, and sometimes they can even seem a bit contradictory.
Okay.
The anthropic principle, it basically reminds us that we, the observers, are part of the universe we're trying to figure out.
Right. We only have us as an example.
Exactly. We've only got one data point for intelligent life us. So making these broad generalizations about probability, that can be inherently tricky.
Okay, so that's one angle. What about mediocrity?
The mediocrity principle, on the other hand, it suggests there's nothing particularly special about Earth or our kind of life. If life started here, the thinking goes, it probably starts on similar planets elsewhere.
Makes sense.
And then fine-tuning. That hypothesis considers whether the specific conditions needed for intelligent life to evolve are actually incredibly rare, maybe finely balanced, like just right.
Okay. And then there's the Drake equation. That always comes up. It sounds very scientific, like a way to actually calculate the odds of finding ET.
Yeah, Frank Drake's attempt back in '61 to, put some numbers on this whole thing.
But can we actually plug reliable numbers into all those variables? I mean, really?
Well, no, that's the key challenge, isn't it? The Drake equation gives us a useful framework, a way to think about the factors involved, rate of star formation, fraction of stars with planets, that kind of stuff.
Sure.
But many of those factors, especially the ones about life actually emerging and evolving intelligence, well, those are still largely unknown. Big question marks.
So it helps us think, but doesn't give us the answer.
Pretty much. It's more of an estimation framework, a way to organize our ignorance, you could say, rather than a definitive calculation.
Which brings us right back to Fermi's paradox.
Mm-hmm.
That deceptively simple question with such huge implications.
Mm-hmm.
If life and intelligence were common, shouldn't we have stumbled across some evidence by now? This great silence, the lack of any clear signs,
Yeah.
it really challenges those initial assumptions, doesn't it, about how easily life might get started?
It truly does. Our source even includes this quote from Thomas Carlyle, looking up at the night sky and wondering, is it full of untold stories or just like a vast emptiness?
Yeah.
It really captures that fundamental uncertainty we still face. Scientifically speaking, we just don't have conclusive evidence either way about how common life is beyond Earth.
And that tension, that's what makes SETI such a compelling field, I think.
Yeah.
Now, there's this common perception, as our document points out, that SETI is sort of fringe science.
Right, like it's not quite mainstream.
Yeah. But the reality is there's been, and there still is, a lot of serious scientific work going into this search.
Absolutely. We're talking concerted efforts going way back to the 1980s, even NASA-supported projects scanning the skies for specific radio or microwave signals that might betray an artificial origin.
And it's not just radio waves anymore.
Well, exactly. The search has broadened. Scientists have also been looking for brief, really powerful pulses of light. Think maybe advanced laser technology.
Okay, so all this looking, all this listening,
Yeah.
and we picked up anything truly convincing. Our source mentioned some false alarms and unconfirmed events. That sounds intriguing.
It's definitely a mixed bag. The document highlights what's sometimes called the SETI episode surrounding the discovery of pulsars back in 1967.
Pulsars. How did they cause a SETI episode?
Well, it was a really significant moment because the signals these things emitted were incredibly regular, like clockwork regular, unlike anything astronomers had seen before.
Right.
So the Cambridge Radio Astronomy Group, they even briefly considered, could this be artificial? Little green men, LGM.
Wow. So for a moment, they genuinely thought it might be aliens.
Briefly, yeah, it was on the table. But as the document emphasizes, when a new kind of celestial thing is detected, the standard scientific approach kicks in.
Right. The process.
The main focus shifts immediately to trying to understand it through known physics, natural processes. Theorists get involved, observers collect more data, they propose explanations, test them.
So what happened with pulsars?
Well, in the case of pulsars, continued research, fitting it into the known framework of how stars evolve, eventually led to the explanation we accept today. Rapidly spinning neutron stars beaming out radiation.
Ah, okay.
So that whole episode really illustrates how science works, how it progresses from anomaly to understanding.
That makes perfect sense.
Yeah.
You see something weird, your mind might jump to the extraordinary, but then the hard work starts finding that natural explanation.
Yeah.
Now, our source then moves on to some more recent astronomical puzzles, things that have reignited that same could it be speculation, and it mentions the crucial role the Gaia mission is playing now. First up, Oumuamua. What was so weird about that interstellar visitor?
Oumuamua certainly caused a stir. It was the first object we ever detected passing through our solar system that we knew came from another star system back in 2017.
And it looked weird, right?
It looked really weird. Its shape was highly unusual, very elongated, like a cigar or maybe a pancake, unlike any asteroid or comet we'd seen in our own system. And that, understandably, made some researchers wonder, could it have an artificial origin, a piece of tech?
I remember that. There were all sorts of fascinating and, yeah, sometimes pretty wild theories flying around.
Exactly. But as our understanding of exoplanetary systems has grown, how planets form and what kind of debris gets kicked out, and thanks, in no small part, to the incredibly detailed data from Gaia.
Gaia again.
Yep. The prevailing scientific view now is that Oumuamua's characteristics are probably consistent with natural processes. We're seeing more interstellar objects now, too. Gaia's precise measurements are even helping astronomers try and trace it back to its potential home star system.
So, while it was definitely an anomaly, it seems increasingly likely to be a natural one. Probably not alien tech this time.
Seems that way.
Okay. What about Boyajian's star? That one had a really bizarre pattern of dimming, didn't it? KIC 8462852.
It did indeed. It was discovered by citizen scientists, actually, through the Planet Hunters project, using Kepler Space Telescope data.
Oh, cool.
And yeah, Boyajian stars showed these huge, really irregular dips in its brightness, sometimes dimming by as much as 20%, for long periods and with no clear repeating pattern like a planet passing in front would cause.
20%? That's a lot of dimming.
It is. And this really unusual light curve led to some pretty intriguing speculation. Everything from massive swarms of comets passing in front of the star
Okay, that sounds plausible.
to the more, let's say, exotic idea of vast alien megastructures partially blocking its light, like a Dyson swarm or something.
Alien megastructures. Okay, now that sounds straight out of science fiction, but I guess if you see something that weird.
You consider all possibilities. And naturally, it became a target for SETI observations. People pointed telescopes at it, listening.
So again, how did Gaia data help with this mystery? Did it find the megastructure?
Haha, no, not quite. But our source highlights that Gaia's contribution was really significant in putting Boyajian's star into a bigger picture, a broader context.
How so?
Well, Gaia's super precise measurements allowed astronomers to identify other stars showing similar, though often less extreme, dimming patterns. These were nicknamed dippers.
Ah, so it wasn't totally unique.
Not entirely, it seems. And what's particularly interesting is that Gaia's big data release in 2018, DR2, showed that these dipper stars aren't just scattered randomly. They tend to cluster in specific spots on the Hertzsprung-Russell diagram.
Okay, remind me. The HR diagram plots brightness versus temperature, right? Tells you about a star's life stage.
Exactly. Think of it as a cosmic census for stars. And the fact that these dippers tend to show up in particular regions near the main sequence, and also in the red giant region, suggests their weird dimming might be linked to specific physical processes happening during those stages of stellar evolution.
So maybe it's something stars just do at certain points in their lives?
Possibly. It makes a single extraordinary explanation like alien megastructures less likely to account for all of them anyway. It points back towards natural, though maybe not fully understood, stellar physics.
So by giving us this much bigger, more detailed map of the stellar neighborhood, Gaia helps us see patterns that suggest natural explanations. It's like being a cosmic detective with much better tools than before.
That's a great way to put it.
Now, the document takes us back a bit further in history, mentioning Nikola Tesla. I actually wasn't aware he'd made claims related to detecting extraterrestrial signals.
He did, yeah. Way back in 1899 when he was doing his experimental work out in Colorado Springs.
What did he claim?
Tesla claimed he detected what he believed were interplanetary transmissions. He even wrote about it in 1901, describing these periodic changes he observed in his signals. He suggested it might be, and this is a quote, a greeting of one planet to another.
Wow. A greeting from another planet in 1899.
It's a fascinating historical anecdote, definitely part of the story of the search. Though it's important to say these claims aren't considered scientifically verified by modern astronomy standards. His equipment, the understanding of radio waves then, it was very early days.
Right. Still, a captivating historical footnote. Okay, now we absolutely have to talk about what is perhaps the most famous, most debated, unconfirmed signal of all time.
Okay.
The WOW signal.
Yes, the legendary WOW signal, August
Sure.
15, 1977, detected by Ohio State University's Big Ear radio
What
telescopes.
made it so special?
Well, first, it was incredibly strong, way above the background noise. Second, it lasted for the full 72 seconds that the telescope was pointed at that specific patch of sky as the Earth rotated. And third, the frequency. 1420 megahertz.
And that frequency is significant
Because it's the natural emission frequency of neutral hydrogen, the most common element in the universe. Cocconi and Morrison, decades earlier, had actually suggested this exact frequency as a potential, maybe universal channel for interstellar communication, like a natural hailing frequency everyone might tune into.
So it hit all the right notes,
It
theoretically.
really did.
And the iconic name WOW that came from the astronomer who founded the data printout, Jerry Inman, right? He was so struck by it, he just wrote WOW in the margin.
Exactly that. That's how remarkable it looked on paper, just jumped right out.
It was never heard again.
That's the enduring mystery. Despite numerous searches of the same region of sky by Big Ear itself and many other telescopes since, nothing. It has never been detected again. A complete one-off. John Krauss, the director of the observatory at the time, even described it as highly suggestive of extraterrestrial intelligent origin, though he also stressed, the need for confirmation that never came.
Did they look for stars in that direction back then?
They did. Initial follow-up searches looked for sun-like stars in that area, but the star catalogs back then, well, they didn't reveal any obvious candidates nearby.
So a strong, narrow band signal at a really significant frequency looks artificial but never repeated, and no obvious source star identified at the time. That is the very definition of tantalizing, isn't it?
It absolutely is. It's kept people guessing for decades.
So how has Gaia, with its incredibly detailed map of billions of stars, potentially shed any new light on this decades-old cosmic mystery?
Okay, this is where it gets really interesting. The star catalogs astronomers had back in the 70s, they were just nowhere near as good as what we have now from Gaia. The precision, the sheer number of stars, it's a different universe, data-wise. So recently, an amateur astronomer named Alberto Caballero used Gaia's second data release, DR2, to really comb through that likely patch of sky where the WOW signal came from.
Yeah.
And among the, I think, dozens of sun-like stars Gaia identified in that area, one particular star stood out as a really compelling candidate source. It's cataloged as 2MASS 1928-1982-264-0123.
A potential solar twin located right in the direction of the WOW signal? That sounds like a huge development.
It is quite suggestive, yeah. This star, according to the Gaia data, has a temperature, a radius, and a luminosity very, very similar to our own sun.
Wow.
It's located roughly 1,800 light-years away in the constellation Sagittarius. Now, crucially, we still don't know if this star has any planets.
Right, that's the next big question.
But just its similarity to our sun makes it a much more plausible candidate for potentially harboring life and maybe a civilization capable of sending such a signal than any star they could identify back in the 70s. It just highlights how much our ability to probe the cosmos has leaped forward.
Wow. So going from basically no promising sun-like stars identified in the original search to potentially pinpointing a solar twin thanks to Gaia data decades later, that's a significant shift in the story, even if it doesn't definitively explain the signal.
It reframes the possibilities, definitely. It gives future searches a very specific, interesting target.
Our source also mentions a message that was beamed out, I think it was on the 35th anniversary of the WOW signal,
Yeah.
towards some nearby stars. It even carried Twitter messages.
Huh, yes, that happened in 2012. An Arecibo message beamed towards some stars cataloged by Hipparcos, Gaia's predecessor. It included crowdsourced messages, yeah, including tweets.
Any word back from ET on our social media attempts?
Sadly, no. There have been no reported replies from that 2012 attempt. But it does highlight that we're still trying, right? Not just listening, but occasionally reaching out, even as we keep analyzing these enigmatic signals from the past.
Okay, so let's try and bring this all together. We've gone through the fundamental puzzle of the Fermi paradox.
Where's everybody?
Exactly. We've explored the ongoing SETI efforts, how they've evolved from radio to optical. We've looked at intriguing signals like pulsars, Oumuamua, Boyajian, star things that sparked alien thoughts, but are increasingly looking like natural phenomena, thanks partly to Gaia.
Mm-hmm.
And we've revisited the big one, the WOW signal, where Gaia has now given us this tantalizing new lid, this potential solar twin. So what's the main takeaway when you put all these pieces together?
I think if we connect all these dots, what really stands out is the power and the process of science itself.
How so?
We encounter the unexpected, right? The anomaly. We might hypothesize about extraordinary possibilities, aliens,
Yes,
megastructures.
exciting stuff.
But ultimately, the scientific method pushes us towards explanations rooted in the natural laws of physics, tested against observation. And missions like Gaia are just revolutionizing our ability to do that, giving us this incredibly detailed, comprehensive picture of the universe.
Which lets us test those ideas better.
Exactly. It lets us refine our understanding of both the ordinary stellar stuff and the seemingly extraordinary stuff. And while, yeah, that definitive proof of ET remains elusive, the very act of searching, of investigating these mysteries, keeps pushing the boundaries of our knowledge. It expands our understanding of our place in the cosmos, regardless of the final answer.
Absolutely. It's a powerful reminder that even when faced with silence, the quest itself, driven by curiosity and these ever-improving scientific tools, is incredibly valuable.
And maybe this leaves you, the listener, with a really compelling question to ponder.
Go on.
Given the sheer mind-boggling vastness of the universe and the fact that we keep finding more and more potentially habitable exoplanets, what do you think would be the single most profound implication, scientifically, philosophically, maybe for humanity as a whole, if we were to finally detect undeniable evidence of extraterrestrial intelligence? Something undeniable.
Hmm.
What changes? It's definitely a thought to let linger along after our deep dive here wraps up.